I'm Dr. Colin Campbell, and this is a Meter Chalk Talk. Today, we're going to be talking more about radiation. We learned in other Chalk Talk videos that radiation was a critical component of an overall analysis of the energy balance. One of our challenges was that this analysis is actually rather long and difficult, but we can get through it by understanding that we're just going to break it up into pieces. And today we're going to talk specifically about view factors. So the absorbed radiation of any object or system that we're interested in is just a combination of adding together the shortwave and longwave components, both the absorptivity of the surfaces and the amount of radiation that's coming in from various sources. We need to focus today on the view factors that tell us a percentage of the radiation that's coming in from a specific source. So I've written down all the sources of shortwave and longwave radiation here, but we're going to focus specifically on the letter F. So there are three sources of shortwave radiation: perpendicular, diffuse, and reflected. And we also learned last time that there are two sources of longwave radiation, both sky or atmosphere and ground. So the amount of each one of these sources of radiation is a percent of a total. And we'll talk about how those are going to add together in a minute. So let's focus first on the view factors. First, we need a definition of view factors. The definition I came up with is this: the amount of radiation absorbed by an object is proportional to the surface area of the object that the radiating body is exposed to. Does that help? I don't know, but let's try to explain it. So there are two sources of radiation. One is a direct source of radiation, something like the sun, but it could be a fire or something else, even a building that was warm. That radiating source is going to impinge on the object we're interested in and look kind of like this that I've shown here in the diagram. There are also other sources of radiation that I like to call diffuse sources. These are sources that come from kind of all over, something like the sky. The sky is always irradiating us, but it doesn't come from a specific spot. It comes from all over. The ground is a similar thing, whether it's reflected solar radiation or if it's long wave radiation from the ground. So that's what our working definition is. But how do we actually calculate how the fraction of that radiation that's coming in? That's what we're going to do now. In this Chalk Talk, I'm going to focus on diffuse radiation. We're going to come back and do direct radiation on another one because we want to focus specifically on solar radiation that's directly impinging on a body. So let's talk about this. I found this picture. It was actually a work of art at the Burning Man Festival in Nevada, but I want to use it for a different purpose. When I look at this, I see a reflected surface that kind of gives me a feeling for what an object might feel like being impinged on by radiation. What do I mean by that? If we look at this object here, it's basically a ball. Our objects that we consider are often not this perfectly round sphere. They're any sort of shape. They're even flat surfaces when we're talking about the ground. But when we look at this ball, maybe we can start to imagine how the different sources of radiation impinge on it. So if we look here, we kind of see the horizon in this ball. Everything above that horizon here, that's reflecting sky. Sky is essentially impinging on that object, irradiating that object from all directions. And the view of that sky for our ball is around 0.5, or half of the object is viewing sky. If you look down at the lower part of this object, we see that half of the object is viewing ground. And typically, if we're doing a really simplified system, we're just going to take those numbers and run with them. So for example, if we said, okay, what portion of the ground is, or what portion of our object is quote unquote seeing or being irradiated by the ground, we would say the fraction of the ground, Fg in long wave, is about, the view factor is about 0.5. Well, what about sky? That's Fa, again, long wave, that's about 0.5. So it would be easy to say that the sum of our long wave radiation, it would sum to unity or 1, but in a simple system like this, half C is ground, half C is sky, and this is our long wave. So what about our short wave? Well, we have to consider that separately, but it actually is going to be seeming quite similar to you. So if we just go back to our pointer here and look at this, now we said long wave sky. Well, there is a short wave component of diffuse radiation, again, not coming from a point source, that just all comes from the sky. As that solar radiation comes through the atmosphere, it gets scattered all around the atmosphere, all around our object, and impinges on the objects from all sides of that object that the object can see, and the half that it can see sky. So we would say then that the fraction of solar radiation, the fraction of shortwave radiation that is diffuse coming from the sky is also 0.5, because as we noted already, that's covering the upper half of the object, that sphere. And not surprisingly, the reflected radiation, what's coming up from the ground in the short wave, and again, we'll note that here, it's coming down here and going back onto our object, that's seeing around 0.5. Now you may say, as we write this short wave, you may say, well, wait a second, there's a lot of things in the object we're looking at. Just a moment. There, it looks like there may be a tent here or an RV over here or something like that. Well, if we want to do a really rigorous analysis of our view factors, we probably would want to include those. It just depends on how careful we want to be about this. So we've considered a case where we're specifically talking about an object. An object could be an animal, an object could be a leaf. But what happens when we consider something like a canopy? They don't look like a leaf, they don't look like an animal, they look different. And how do I mean? If we put a reflective surface on this area, we wouldn't be able to see the ground anymore. In fact, the canopy kind of visually makes up the ground, and we describe it that way sometimes. All this canopy can see now is sky. So how do we represent that in our model? Well, let's again first consider our view factor for the atmosphere. How much atmosphere does this grass see? Well, I would argue that it sees all of it. That's all it can see. And maybe you'd say, well, wait a second, around here there are some trees, and it does see a little bit of tree. And I would say, hey, if we're going to be able to do a little bit more rigor in our analysis, and that's not much, I'd agree with you, maybe 10% trees. That's what's happening in this picture. But for our analysis, maybe we just want to consider just, let's say halves or ones. And then we could say, okay, in this situation, that canopy, that really only is seeing 100% sky. Well, if it's seeing 100% sky, what is FG, our ground view factor? Well, that's 0, because it's got to add up to unity. And so this is our long wave radiation. Now let's talk about the short wave radiation. For our purposes, we'll assume that canopy is taking up almost all the incoming radiation. Therefore, there's really not a source of reflected radiation coming back into that canopy. So what that means is, if we go down here, again, we have a source of radiation coming from the diffuse. What amount of the total shortwave radiation that's getting in here from diffuse sources is coming from diffuse sky radiation? Well, again, it would be around 1. So how much is being reflected? Again, we could spend a lot of time debating this, and there is some reflected radiation coming into this canopy, but not much for our energy balance analysis. For our full radiation analysis of this system, we're going to call this 0. So again, this is our shortwave radiation. So in the end, what we're talking about is this. We said that there were 5 sources of radiation in any system that we're interested in. The first comes from the atmosphere in the long wave, the ground in the long wave. Then we said also there was a diffuse from the solar, and we said there was a reflected from the solar. Now we know all the details we need to be able to calculate them, and there are really only 3 different conditions. 1, whether we're dealing with an object such as an animal. 2, whether we're dealing with something like a leaf specifically, and we said those are close to each other. Half sky, half ground, both for long wave and short wave. And then we said there was one more condition, that was if we had a canopy. And we only see sky when we have canopy. So both the short wave and the long wave is just atmosphere and the diffuse radiation. And so we have all these sources of radiation kind of taken care of. The thing that we don't know yet is this last one, the perpendicular. And that one we're going to leave for another Chalk Talk. Thanks for watching. Please check out our other Chalk Talks on our YouTube channel. Be sure to subscribe and go to our website to look for more great content.